Let's take a look at this example. Okay, so first of all, we're supposed to check if this circuit is operating correctly. So what I would do first, because I have this current, right, and I have these two resistors, I would find the voltage at this point. This is my X. I'm going to call this Vx. Vx is going to be equal to the voltage across these two resistors, okay? So I have this current, let's call this I4, or this could be called also I3, I4 times R3 plus R4, okay? This current times the resistance of these two resistors will give me voltage at point X. So Vx is equal I4 2.307 milliamps times R3, which is equal 1K plus 4K. So Vx is equal 2.307 exponent 3 negative times 5 exponent 3. This is equal 11.53 volts. Okay, so this is voltage at this point, right? Now, if I'm going to add this voltage to this voltage, theoretically I'm supposed to get voltage source. If everything is fine, so I'm supposed to obtain 20 volts. If I'm going to get different voltage, so it means something is wrong. So voltage source is equal V1 plus Vx. This voltage plus this voltage supposed to give me voltage source. So V1 is equal 10.768 volts plus 11.53 volts, right? So this is voltage source is equal, we can see that it's not going to be equal 20, but simply calculate 10.768 plus 11.53. This is equal 22.29 volts. 22.29 volts. Okay, so it means that something is wrong in the circuit, because this voltage, right, voltage source is not equal, right? This, let's call this VSX. Okay, it means that we have to compare our X scenario to the voltage source which we got over here. So we can say that voltage source which was given is not equal to VSX scenario. Okay, so it means there is something wrong in this circuit. Now, what is wrong in this circuit? Please notice that we got the voltage across resistor R1. So R1 cannot be shorted, because if R1 would be shorted, we would measure over here 0 volts. If R2 would be shorted, right? R2 would be shorted, so it be measured over here 20 volts. Okay, if you would short this resistor, because you will simply measure the voltage source across this resistor. So there is something wrong over here. Now, please notice that the voltage which I obtain, right, is higher than this voltage. Okay, so I would assume that there is probably something wrong with this resistor. Okay, because higher resistance in this branch will cost me higher voltage over here. Higher voltage plus this voltage, right, will give me simply higher voltage source. So I assume that this resistor is short. It cannot be open, because if this resistor would be open, you would measure over here 0 milliamps. Okay, so what I'm going to do, right now I'm going to just short this circuit. Okay, I'm going to short this resistor, and let's check how many volts I'm going to get again over here. So this resistor is shorted. So let's calculate Vx again. Vx is equal, in this case, my current I4 times R4 only. So this is equal 2.307 milliamps times R4, which is equal 4 kilo ohms. So this is equal 2.307 exponent 3 negative times 4 exponent 3. This is equal 9.22 volts. 9.22 volts, right? So my Vx is equal 9.22 volts. So Vx plus V1 supposed to give me voltage source. So voltage source, okay, is equal V1 plus Vx. Okay, so V1 is equal 10.768 volts plus Vx. Okay, this is, let's call this maybe Vx2. Okay, this is like the analysis after finding the problem in the finding the problem in the circuit. So this is going to be equal, okay, this is going to be equal 10.768 volts plus 9.22 volts, and this is going to give me 10.768 plus 9.22 is equal 19.98 19.98 volts. So this is approximately 20 volts. So it means that my circuit R3 is short. Okay, we found the problem, because if you are going to remove this resistor and simply close the circuit and find the voltage across this resistor, this is going to be my Vx plus my voltage across resistor R1 will give me 20 volts. So it means that R1 is short. Okay, so we found the problem in the circuit, and this is basically the solution to this problem.